All right, let's talk about velocity graphs. So on a velocity graph, we're now plotting not where you are, but how fast you're moving. And velocity can be positive or negative. So in this case, everybody is moving in the positive direction because the velocities are positive. So the slope of the line has nothing to do with the direction you're moving. But if you look at the units of the slope are going to be meters per second divided by seconds, which is meters per second squared. So the slope is your acceleration. If you have a positive acceleration, that means you're accelerating to the east. And if you have a negative acceleration, it means that you're accelerating to the west. So if your car is moving to the east, which is what this car is doing because of the velocity values, and the acceleration is east, then it's going to be speeding up. In this case, over on the other side here, the acceleration is negative. The car is moving to the east because the velocities are east, so it's slowing down. And if there's no slope, there's no acceleration. The other thing is that the area under the curve is displacement. If I want to know how far I've gone in the first 4 seconds, I literally block this into a shape, and that area is 1/2 the base times the height of that triangle, which is 1/2 the base, which is 4 seconds, times the height, which is 8 meters per second. It's positive 8 meters per second for displacement. So 2 times 8 is positive 16 meters is your displacement. If I wanted to find for the next 3 seconds, I could block that off. And it would be 3 seconds times 8 meters per second, positive. So the displacement would be positive 24 meters. This is 16 meters, right? And together, from 0 to 7 seconds, we traveled 16 meters and another 16 meters. They're both traveling in the same direction, so you just add them together. The total displacement would be 16 plus 4, which would be 40 meters. The distance would also be 40 meters because they're traveling in the same direction, right? You just add those together. All right, let's look at a graph that shows us this relationship. So what we want to do is we want to look at so let's take a falling object. Here's the dot diagram. You see, as he falls downward, his acceleration is downward. So he's increasing his speed as he falls down. Notice I told you that on the velocity graph, you can have positive velocities and negative velocities. Notice that the velocity graph only plots negative velocities over time, because as it falls, it increases its speed, but it's falling in the negative direction, so its velocity in the negative direction is getting bigger. Also, notice that the position graph is a parabola showing acceleration. Now, if we say that the acceleration is negative 10 meters per second squared, the slope of that velocity graph is from 0 to negative 20 in 2 seconds. So it fell 20 meters per second, and it did it in 2 seconds. So its slope is negative 10 meters per second squared, and its acceleration graph is plotting at a constant negative 10 meters per second squared. Its position graph is a parabola, and the slope at every instant is getting steeper and steeper in the negative direction. So if the position graph is linear, the velocity graph will be flat. If the displacement position graph is parabolic, the velocity graph will be a line, and the slope of that line equals acceleration, and the area under that line equals the displacement if you take into account the direction, or distance if you don't. And the slope of this graph up here is meters per second, or velocity. All right, let's explore again. We're going to play graph that motion. So we're just going to do a couple of examples here. And we want to match the motion to a position time graph. So let's first look at this. It's moving in a positive direction at a constant speed, and then he stops and he accelerates. So what would the position graph look like? Constant speed, stops, and accelerates. Constant speed to the right. So we would want a graph that shows a position graph of constant speed. This shows constant speed. And then we would want it to stop for a while. And then we would want it to speed up in the positive direction. So it would need to be a parabola of some sort. So let's see. Oh, there it is. Constant speed, stops, accelerates upward to the right.